I'll start with kind of the motivation behind how we got here really briefly. When I first joined, I kind of came on to the experimental side of the lab where we're working on the vacuum chamber to initialize electrical breakdowns. And when I came in, they were trying to automate the system a lot more. Previously, it was just it was still automated. Jared did a really nice job of automating through LabVIEW, but there were some things that we were adding in new components, wanted to automate some of the pressure valves and the gas flow and a few other things like a linear feed through where we can, I don't know. Did you show the video of it? Yeah,
Yes.
okay. The video that was in his thing.
That's when you saw the animation where it touched the two plates touch each other in the back. So that's fully controlled. That's one of the first things we automated, I think.
Yeah, that was something that we wanted to take on, and it was difficult to do that with LabVIEW. So that's kind of where I came in. I said I want to learn Python, and so Ryusei said, all right, learn Python and kind of implement some of this stuff, and then come back and tell me what you did when you learned Python. And so while I was going through, I kind of refreshed on my computer science basics, just really easy stuff, and then but using Python. And then after that, I was able to start picking up, all right, how can I apply this to the problems that we have to solve in the lab? And how can we start implementing things? And so I got in and we implemented that feed through first. And then I was like, all right, I don't want to learn LabVIEW. So I started taking everything we had in LabVIEW and transferring it to Python, which
we did that. Can you show the workflow?
yeah, okay. So when that was going on, I took all of what I did learning Python and transferred it into a Google Classroom, and it's also in GitHub, like a workflow for doing what I did, coming in and learning Python. You could come in with no programming experience. I did have programming experience, but I started with just what do I need to do Python? So it's kind of like using these different libraries. We used Lego kind of smart bricks, are like Raspberry Pis, but they're connected to Lego.
They are ARM11, I think. 9
Yeah.
11.
Okay.
The Lego type bricks.
Yeah, I guess the same as Arduino chip, right? So, yeah.
Yep. Yeah.
So what, they have like sensors in them, or?
Oh yeah, you can have you have gyroscope, you have pressure sensor, you have like force sensor,
And they've got ports, they just plug and play. You say, oh, I want to put in a motor, I want to put in a sensor, plugs in, and then you can start programming using that sensor.
Like very modular.
Yeah, oh yeah, very modular.
The Lego, so
Yeah.
Yeah, it's like the Lego Mindstorms. It's adjacent to the Mindstorms if you ever used those.
replace them.
Yeah.
Didn't have that when I was a kid, unfortunately.
Ah,
I had
well,
log bricks.
I didn't get any of those. Couldn't afford them. The
Yes.
computerized Legos, so I didn't have those, but I knew about them. I had friends that had. So anyway, we were using that, and those primarily work on their own kind of sub-coding language, sort of like how Arduino does, or they have a block-based one. But people who use these for like competitions. There's a whole competitive Lego building robot world, and they do it in Python. So they've kind of restructured an OS for that, and you can use just straight regular Python with some packages on these Legos. So I learned how to use that, and then how to use Google Colab, which is for reading Jupyter notebooks and all that. So that's one of the things that I looked at was, and we set it up here. This is kind of explains, all right, here's the really basics to even use this, to even start to learn. This is what you need, using IDs and all that. And then I go in and I started reminding and learning the basics of just programming. So, I mean, for example, this one would be, I can open it up, show kind of what it looks like when you open it. It shows up and I just start explaining kind of what's going on. What are we working on? Explaining a little bit of error checking, how you can understand what it's telling you. And then we get down and what are variables going all the way through. And then what we're working on is adding in, I don't know if I did on this one because it was so basic, but adding in like, I can't find adding in little exercises you can do in projects. So like this first thing right here, right away, we've taught you something. Now you go into a project, apply yourself. And then moving on, we have something more, a little bit more advanced, and it's just this is all about lists, right? And it teaches you kind of how you make them, what you do, and then I believe in here I did add in. Yeah, so here's like an exercise. About middle of the way through, you've learned some stuff. Here, just do this really easy, simple problem. And I think I have some more at the bottom. Do some more advanced problems. And then at the end of a whole section, you have more projects. So here's a project, here's a project, and then once you get to the end and you've made classes, you kind of start to understand the object-oriented aspect of programming, and you're like, all right, I know what I'm doing now. I can make functions, I can make objects. Time to move into what I really want to do, which is maybe some sort of lab work. And so that's where I get into kind of all the modules and libraries that you would install. So we're going over NumPy, which is what I primarily use when I'm doing large data sets. I might also add in something for pandas because people use that too. SciPy is really good for numerical integrators and integration and different derivatives and all that, but on a non-symbolic side, just straight numerically. SymPy does the symbolic aspect of it. Matplotlib is for plotting, and then I'll add in a few more for like tkinter, which is for what I use to make GUIs, and PlasmaPy and AstroPy are some that I also want to put in because they're kind of specific for a particular field, and AstroPy is very widely used in astrophysics. PlasmaPy is kind of on its way up. Some people use it.
For tkinter, have you made like a GUI interface for controlling instrumentation? Or
Yes, and I can plug in my Mac and show it because I don't have it installed on here.
Yeah, that's cool.
And it would probably throw a fit if I tried to. Actually, at the end, I'll see if I can run it on here because what I added in is something that when you boot it up, it downloads all the dependencies that you need. And so we'll see if that'll work on a computer that doesn't have them. That would be really cool, actually. So we'll try, I'll go through that afterwards. And then after that, we go into kind of specifics. You want to know plasma physics, here's some, there will be more, but here's some lessons on plasma physics, some applications, particle and field particle tracker.
Did you fix this one yet?
That
link.
No, I don't think I did. Sorry.
Particle in field is funny because that's basically one of the assignment Carol was giving to one of her students. So again, it stems from the idea that every faculty has a set of problems we assign to our students to bring them up to coding skills for research. Say, well, let's try to provide that and encourage people to bring their own exercises, and so that's where it's stemming from. And Seth has been implementing that and have been just
Yeah, but okay, this is amazing. You did this.
Yeah,
last
that's
year.
awesome.
Yeah, it's slow going because I also have on the side, it's like I have classes and then also lab work, but yeah, it's it's hard to also be making this whole thing, but it's been
A lot of
going
work,
well.
yeah.
And that's kind of what we've been hoping to do at this trip is get some outreach going, so that way we can get people who are also interested in it to come back and say, okay, this is what you need.
Mhm.
You know, this is something that I totally have to do, but I totally want you to do. You got to add this, and I like be like, okay, can you give me a hand? That kind of thing. Can we get some like a little bit of collaboration in developing it too? So
Yeah,
that was,
awesome. Do you have any image processing algorithms on here?
I don't, but I know that there are some, and it
That's
definitely could be
future
something
I
that
can help
that you
contribute,
could
'cause
add.
I do
Yeah,
a lot of that.
yeah.
that would be awesome because I
Which is the
don't
lab
know.
work, right? Is
Look, the photometry time series.
Yeah.
It's not even. I mean, we didn't write that. It's a colleague, an astronomer.
Yeah,
Tomomi Otani, that's Dr. Otani that did that module. So we welcome that simply because I'm just thinking, okay, what people do, they do robotics, they do data analysis, and they do control, they do modeling. But no, I didn't do the image processing. So yes, I would absolutely.
Yeah, and
it's all super simple, but stuff like
That's what we're
just
looking for.
automating background subtraction, edge finding, thresholding, just standard simple stuff that
That's
is like
exactly what we were looking for.
it's pretty crucial to most lab work. So.
Yeah.
I know in the linear algebra class at our school, they do that. They learn Python and use linear algebra. You can like image processing is so much of that.
It's just matrix.
Yeah,
algebra,
just matrix
yeah.
stuff. So I mean, they're like, all right, take this picture and you're gonna remove the background, or you're gonna. I think what they did was you get a whole bunch of the faces, and then you find like the average face of all the people or something like that, because something along those lines. And I was like, oh, that's really cool, but I don't know how to do that. So that would be something where that'd be really awesome if you could help and put that in. Because
Yeah, and
I
I
would
think
not be able to.
one of the most useful things would be some kind of automated algorithm with a GUI where they can select a point in the image after they do that processing and start measuring like distances and velocities if you're tracking fluid flows.
Mhm.
So if we had a module like that, does all the pre-processing, then gets it ready, then you select the origin point, you know, your pixel to centimeter ratio or whatever. And then they can just manually like measure things and then get a time series.
Yeah.
That would be
That
really
opened up a
cool.
lot for
Yeah.
people working in the lab.
That'd be really cool.
Yeah, absolutely.
Yeah.
Yeah.
I have some MATLAB codes to do that, but I want to transfer all my stuff to Python because, like you, I'm trying to learn more of this.
And this is open source too, which is
Yeah.
part of the push, is that it's and especially in the kind of academic and scientific field, it's nice
Yeah.
to be open source. You don't want to be
Oh,
tied to
nice,
proprietary.
and NASA is required.
Now it's a requirement, yeah.
So-
Yeah, my NSF grant requires
So
most of my stuff to be open source anyway.
So that's another part of the push for this. So the
actually, one thing for you, MATLAB as an export to Python now.
It does.
really? That's cool.
Also, like I use Perplexity AI for like help with coding. I'm pretty sure I can upload it to that and it'll just convert it to Python.
Oh yeah.
My wife has been doing that.
What's the name of it?
It's Perplexity AI. I like it better than ChatGPT because it shows you all the websites it's like trying to use to get you the answer. You can
Right.
click on them and go
Oh yeah, that's a lot better.
investigate because you don't want to just blindly trust it. But for like coding stuff, it's excellent. I
Mhm.
mean, it's
It reads like forums, it can find specific libraries if you're looking
Yeah.
for, if you're using a specific sensor, it'll look through different like Raspberry Pi Arduino forums, find that sensor and then learn how to integrate it into like C++ or Python code.
Oh, that's cool. Because I think with ChatGPT, I've noticed that it is starting to do like finding links and all that. But normally what I'll do is I'll find my manuals, I'll find my stuff, and I'll just upload it to ChatGPT, says, read this manual, and then now help me integrate it. You know, tell me what am I looking for? And
yeah,
that's
Perplexity is more efficient.
yeah.
I got recommended to it by a friend who works in Google. He's
Okay.
pretty high up in I think like I have friends in software development, work for Rivian and stuff, astrophysics buddies, like we code in full senses now. We don't even. Now you don't want to just blindly copy from it. So when it gives me some new code, I copy it line by line to make sure I'm understanding each line.
And usually there's a bug or something in it.
There can be if you try to get it to code up like some physical model, it'll
Yeah.
often mess up. It won't get units correct, consistent. So you gotta be very careful. But for just like straightforward coding stuff that like there's already lots of existing codes and algorithms on the internet, it's really good at just finding that,
And
giving you a
consolidating.
very concise,
That's good. That's really good.
streamlined
Yeah.
coding answer to it that you can use, and it'll clean up your code too. So like you know how you're like beta testing a code and you've got comments and all this
Yeah.
stuff. You can just give it to it when you're done, and it'll just clean it all up, and make it look nice, save you some time.
Very cool.
Yeah.
That could actually be something worth putting in here. Maybe like the intro is how to use AI to like code, like improve your coding efficiency, like how to, instead of just saying, oh, here, solve this problem for me, and then copy pasting it, like kind of just a quick lesson, like this is best practices when working with AI and coding.
Yeah, I
Really
think
cool,
that's the
actually.
way to couch it, best
Yeah.
practices. You know, you don't want students just slapping everything in, like writing a code to do this and then not critically thinking about how the code should do this.
Yeah.
But like for me, I don't know what the function names are in Python. So
Yeah.
I say, you know, this is what I do in MATLAB. Where's the function I need in Python?
Yeah.
How do I compile
Yeah, I
it?
do that a lot too. Or I'll say, all right, I need to do this. I know it's possible. You know, what would be a flow, like what's an algorithm I should try and use, or what's a
Yeah.
library I need to use, and it goes out and says, this is the at least a starting point, and then
Yeah.
sometimes I have to modify it. So
And I mean, realistically, like students are using AI to code. I mean, it's
Yeah.
just like,
I agree. So that's good.
well, I remember in the 383 orbital dynamics, Jared was he was a grader, and he would say he would see answers where it still has the like all the very just like trademarked like ChatGPT comments, like
Yeah.
like it is, you can tell when code is ChatGPT written because just the way that it writes it.
Yeah.
He's like probably like 40% of them I know they're using
Yeah.
ChatGPT just because of that. And I was like, you know, it's like, what can you do though?
well, it's like with Google and Wikipedia came out, I remember when there's resistance and then now we all use it, so.
Yeah.
It's the way it goes. But yeah, so I'll keep that in mind. Actually cleaning up my code and making it nice enough to put on here, you know, that may take until like August, because I have a big conference coming up and everything, so.
Oh, that's totally okay.
But-
Yeah.
You know, it might be something I'll try to work on and make like modules or little packages that could.
And that's,
Okay,
we're
we're
putting
configuring.
together teams, pretty much that can be
Yeah.
for that, you know, we
Yeah.
collaborate in there and say, all right, this is something I want to add in, what, you know, what do we think about this kind of thing? So I think that'd be really good.
The
Appreciate that.
webcam thing, like.
Yeah, any and all sensor
Yeah.
information I can help contribute as well.
That's awesome.
Yeah.
Yeah. Well, and speaking of sensors, I can get in and show what the main course is here is I'll show you how we're working with some of our sensors. I don't know why, but the DAC, when we plug it in, it just
Yeah,
doesn't work.
Evidently, we needed a new driver, so I tried putting a new driver in, but I still think there's a couple more steps to.
Yeah, it's because it turns on and the computer recognizes that it's plugged in, but it doesn't recognize that it's a National Instruments DAC, and so we can't communicate to it. And I don't know what's up with that. But anyway, I can show the oscilloscope, which is really cool. So I'll go through.
Just thinking how we can move the computer to see the oscilloscope so that the webcam.
Yeah,
I think,
I think I can unplug this. I don't think it needs to be plugged in just yet.
good. Can you put the oscilloscope on that bench?
Yeah, that's probably best.
So that I'm gonna put the oscilloscope on the bench and
need to.
yes, we need that as well. Yep.
So for the. This application, basically what you're showing us now, we could do it on a Mac, but like going to Netflix for the.
Cannot do it on a Mac.
Cannot do it.
Yes, we tested fairly extensively.
So it's
while
actually
at
the
the beginning of
Python
the week.
library that has the issue, is that right there?
It's okay, I'll actually I can get into it a little bit,
Yeah.
but it's a combination of things. It's mostly the Mac that doesn't have drivers for pretty much everything that you need to do. I kind of go into it at the beginning.
Does it work on Linux?
It should. I don't use Linux, so I haven't tested it. Oh, okay.
Okay.
Yeah. So basically, when you're communicating with all of these devices, they are governed by the IEEE like 422 point or 488.2 governance. They said, okay, all measuring instruments that we use have to be communicate over GPIB with Visa protocol, and it has to use SCPI commands, which is this particular type of command syntax that they want to use. And so it uses a specific communication protocol on a specific line using very specific commands. And that's how all instruments work. That's how they have since that was declared. Your computer usually comes with a Visa driver. So Windows computers always have Visa drivers. I believe that you can install with not a lot of work the Visa drivers on Linux. It just and especially PyVisa, which is the library that I use in Python, it comes with the drivers that you need to communicate to it. Show that kind of jump. Maybe I should change the order of that. But PyVisa-Py is part of the driver that you need. ZeroConf helps it identify USB devices and understand that USB is able to communicate through this previous protocol because it was designed before USB was a thing. Now USB is, and we use that. So you have like a little bit of a transfer driver that you need, and so that's what that is. And then Windows usually has just the regular Visa drivers. I believe on Linux you can do it. Mac, I think they might be there, but it's missing something else, and it just doesn't really work because we weren't able to do any of this demo on my Mac.
Yeah, I mean, I guess that's why we have these PCs basically. Is to kind of, because again, so many other things we have to control with PCs. So
yeah, it's quite unfortunate, and maybe if Mac becomes dominant enough, they'll force them to like, all right, you have to put in these dependencies because people need to. You have to align with the rest of the world, or maybe the rest of the world will come and meet Mac where they're at and say, all right, we'll develop a new protocol that you can use or something like that. I don't know. Probably not, but at the very least, right now, no Mac. Linux, everything I've seen whenever I'm installing stuff, Linux is named. You know, even though
Yeah, I would think so,
Yeah.
because that seems to be like a big
I think
popular OS with developers.
yeah, people like Linux a lot. So I'd imagine I haven't tried it, but it seems
Use it
more.
on the pies, and I mean it's straightforward, and especially if you're just doing things through terminal. I mean it's
Yeah. So I think the thing that just complicates it is communicating with these devices. They have a specific protocol they want to use, and I want to say you can do it on Linux, but it's worth testing. If you guys use Linux a lot and you're like, oh, we'll run it on a Linux machine, and you come and say, all right, you can't do it, or hey, you can. This is what you have to do. That'd be really useful because we don't use Linux over it.
I suspect, like, for example, Zach might run like a tkinter like sort of application on Linux sometimes, just to make it, if you, let's say we have another undergrad coming in and you want to like automate some of your things, you just want to hit a couple buttons and change a couple of dials, or a tkinter might be good for that, right? So
Yeah, developing like a GUI, especially with like cameras or sensors, may be a good
yeah.
Approach.
And you never know, with the Magma code, I put a GUI on thinking, oh, this is for somebody else. But then I ended up starting using it myself because it was handy. So
I was just saying for the image process, saying
Yeah.
like, that would be great too. Yeah, it's.
I ended up doing sometimes if I'm integrating like a new thing, it's just way easier to just write up a really quick GUI, and it's like, all right, now I can talk to it better. Yeah, it's otherwise printing stuff to terminal or whatever it's acceptable, but it's kind of nice to have it print out nice and it looks all pretty, and you can change stuff real easy from a GUI, and that's good. So once you have all the drivers that you need to communicate with Visa, you install PyVisa, and these are kind of this is the command format that you'll use. So you always have, and all of these will be found in a programming manual. All of these devices, it doesn't usually come with a device. You have to go to like maybe Siglent or Tektronix. You go online, you say this device programming manual, and it pulls up a manual, and it'll be like 1,000 pages long, and it'll show all of the functions that this thing has and how they're laid out. So usually you'll have a header function and then maybe some sub functions, and then they'll need some arguments that you send. Or if it's a query, if you're saying I want to know what the value is, I want to know what this parameter is, throw a question mark at the end and it returns it. And all of them will follow that same format. They all look like that. So for example, if you want to set the acquisition mode on your oscilloscope, it would look like that. You have acquire, mode, and then high res. And what's interesting about it is that they'll have this weird combination of capital and lowercase letters. Capital letters are required. Lowercase letters are optional. You can't, from what I can tell, just throw in a bunch of random lowercase letters. It has to be those lowercase letters, but they're optional. If you want to shorten it, you can. I just always write the whole thing because then I actually know what it says. Because like that just is kind of confusing, but it is allowed. For example, so this one here that we have, this is the programming manual. I just went on, actually, no, it's not. This is the other one. I swear I changed it out. Okay, this was the other one we're going to use. But it would look like this. Look, it's like 1,000 pages long. You go down and acquisition commands, and it explains what they do, what you need, and all that. So this is like the Bible when it comes to controlling these guys, because it tells you, and a lot of them will overlap. So like this oscilloscope has a lot of the same ones as this oscilloscope. They're mostly the same commands. There's like 6 regular commands that are universal across all of them, which was one of the things that they said had to happen. And let's see, I've already installed PyVisa and this, but I'll go through and do it again. Okay.
And theoretically, if the DAC is working with a very similar process, and then
Yes.
that would be good. Trial for me to do that working.
Yeah, I'm gonna get this new DAC probably on Tuesday. So
Try that one too.
start playing around with that and see how that works.
Okay, so I'll do the demo here, where we'll start with, these are the packages that you need to install. So PyVisa is important. Is it running? I think it is. Yeah. Okay. Yeah, it's thinking real hard. I noticed this computer was a little slower than I was used to.
I have one actually too. I'm gonna go get myself some water.
Makes this.
Okay, there we go. It's working now.
I need some bottom water though, that was a terrible.
So then we can import those. I guess I'll wait for him to get back.
And so are you running all of these commands like through the kernel?
Yeah, so this, I usually don't use Jupyter notebooks for this. I'll make a whole separate thing, but you follow the same work. But yeah, usually I set up a virtual or a
Like
virtual environment. Yeah, a virtual environment. And then I'll be like, all right, this is my virtual environment for this thing. It has all the packages and then they're not on the main machine. So the main thing that you need for Visa communications is a resource manager. So you make a resource manager object and it just can identify all the stuff that's plugged in. So hopefully this will work. And then actually I'll just go in and print out that list of resources. That was right.
You forgot to plug it again?
No, it's plugged in. So it's the peril of live demos. You did some magical thing whenever you plugged it in, so maybe you're better. Because I thought I had it plugged in last time too. Oh, this is the wrong one?
No.
No, that's the charging cable for this computer.
No.
Oh, maybe turn it off and turn it on. That's my best attempt. Did it turn off? I thought it.
See if I find the cable just in case. Perils of live demos.
Yep. Never seen a live demo go right.
Oh, you saw my experiment yesterday.
It's almost a guarantee. Yeah, maybe I'll try this cable.
I'm sure that solenoid valve will work today when I try it. When it's just me in there.
Did it not spin?
There we go. All right, I heard it connect. All right, so this is what it'll look like. This is the identifier for this oscilloscope. It has connected. So then we'll want to open that resource, and then whenever you open a resource, it's best to close it afterwards. This is one of these universal commands. The identifier says, "Hey, what are you called?" And then this is usually just a really good test to make sure that you're connected and you're connected to the right thing. So then it returns. It says, here's my address. This is the name." If we want to, this is one of those other functions that a lot of them have, which this will take away the header when it outputs. Although whenever I tried it before, it didn't really work. So then it will know it's communicating, it's sending out outputs every time we send something in. So we can kind of change, if you,
The output is not this, there you go.
yeah. So if we look here, I can change I can change the horizontal or voltage divisions. So maybe if I go to like 2 voltage division, it changes how many volts per line, right? And so then do the same for time and get more lines in there or less lines. And that's just you're setting the screen size here. So then
This is awesome.
I
That's
can
from computer
to oscilloscope.
Yeah.
Yep.
And the next step is to do oscilloscope to computer.
Yep. So here I'm querying, I say, I want to know what the time divisions are, how much time per line, and it's telling me, saying this is the value here. And so that COM header up there is supposed to take this off. So maybe it isn't. This might have been from the other device and it doesn't work on this one. That's one of the ones where you really only know that the ones with the asterisks are going to work. Aside from that, you got to be in the manual. So what I've got here, this is just a really like short thing that tells it to start reading this waveform and store the waveform. And it says, all right, I'm going to store from 0 to 1,000 seconds, or I guess I think it's milliseconds. And then we can query kind of the sample rate and the time divisions, the offset, all that. And these values will be useful for when this tells me the waveform data, it just gives me a bunch of numbers and then I can plot it, but it has no actual meaning behind the numbers. And so you have to use these values from the screen to return the actual meaning into the numbers. So if I run this, it'll probably take like a couple of seconds.
So fundamentally, it's just like giving you the position on the pixel position.
Yep.
And you just use that to convert it into exactly what you're saying.
Yeah, yeah.
You know, with the image processing, what's the velocity between 2 points? Well, you have to convert a pixel into a distance. Yeah, that's exactly what this is doing.
Right. That you had some indice ranges there.
So that was because the COM header did not work. So we can see when we're looking at that query there, it gives me this stuff, right? And I can't plot the letters. So we remove all of the non-stuff. So that's
Yeah,
where that,
So you took the string.
yeah, I took the string and
from the 4 to the what? So, yeah.
Well, this stuff here, would these be things you ever have to change, or those just always?
Yeah, it just look, so if I read it right, so it return, that is a string, right?
Yeah, yeah.
So it's taking what, the fourth character?
I gotcha.
So 1, 2, 3, 0,
Gotcha.
1, 2, 3, 4,
So
and it probably end to what, -5.
and negative, you start from the back and you go backwards. So actually,
0, 0, 1, 2, 3, 4, well.
so that's, I mean, yeah, that was, the sample rate would be a different one.
Oh,
So,
yeah, that's not the difference. Which one is that one?
Time division is -3, so yeah, you,
Or
So yeah,
That's more
-3, the 4, you know, I'm assuming it starts at 0 or 1.
start to 0, yeah.
So yeah, so basically it removes this 0, 1, 2, 3, 4. So starting at this space, and it takes out the last 3. I think it should have taken the last 4 character actually. Or it takes no, so
It doesn't
no,
include the apostrophe.
Yeah.
1, 2, 3. So,
Yeah.
and then so basically what it does, it just takes this part of the
number.
string.
Yep.
That's
So-
what it-
Okay.
Ideally, you don't have to do that because you can take out the command headers, but when I put that in, it didn't work. So that's something that you just got to look. But it is something that you can do. You can say, I don't want command headers, and then you don't have to worry about that. But for the sake of this, I didn't want to read the manual in that much depth. So once,
So it's just string manipulation,
Yeah.
if you do need in MATLAB, it's the same thing.
Yeah.
so then using NumPy and Matplotlib, and the sys is the system library. It's built into Python,
Yeah.
and it helps with, I guess here I'm using it for the byte order. And then we can use all the stuff that I queried before and refix the data that we got, the waveform data, and turn it into a plot for the waveform. And we do this whenever we're measuring the peak that you get whenever a electric discharge is detected in our system. We pull the waveform and we plot it, and I don't think we actually need it. It's just fun to look at.
So when you hit that command, it's almost like that's the trigger. This particular instance, is that right?
For us, we have the oscilloscope in trigger mode, and we're saying, okay, we're gonna wait until you get a signal that passes this amplitude, and then once you do, then do all of this stuff.
Okay.
And so it'll say, the trigger will send a thing here that says, all right, hey, we triggered, and then the computer will say, all right, we got a detection, run all this other stuff.
And you set the trigger mode from the computer?
I set the trigger from the computer,
Okay.
and whenever it's done, it sends it over here. And then you can reset the trigger from here if So every time it starts, it sets the parameters again. It says, all right, we're gonna wait at 0 and we're gonna wait until we get this. And then if I wanted, I could tweak it all from the computer. Yeah. Some devices don't like when you do both things. So if you're like, oh, I need to change something, and then you change it on here, it'll override and it'll like cancel the communication along the line to the computer. Yeah, a lot of them don't like when you do both things. So you got to pick one pretty much.
Your plot up there is time with voltage data on the y-axis,
Yes.
right?
Yeah.
How are you getting negative time?
Probably just didn't do it right.
So negative time, I'm assuming because you put 0, 0 at the center.
Yeah, I think that is, it's because we're saying the center of the time is here.
So if you adjust that slider on the oscilloscope, will it adjust like the starting time?
Yes, yeah,
Okay.
and you can do that in the code here. That would be this offset, I think, or and I believe that's where that could be the vertical offset, and then there should be a time offset too. That's where is the center of the thing. Yeah, it's definitely something that we do, like we don't use the oscilloscope as much for precision. So like I did all this, and this particular one, this read raw, is just taking just the raw data from it. It has a read binary and a read ASCII, but when I used both of those built-in functions, they didn't work. So I had to redevelop like this whole deal, which was where I kind of converted it to, I think, yeah, decimal or whatever, and then it was useful. And I struggled with that for a while. So that I was like, all right, we don't, I once I got it, I was like, I don't really need to go back to learn. But that's where, if you're like, okay, I need to make sure my offset is good, that's where you go into the manual and say, all right, what are my functions? What am I looking for?
Can you do a demo, like change the periods or decrease frequency? No, increase the period, decrease frequency by factor 5. Run it, and you should basically. How did I break it?
I think I closed it at the end here.
Yeah, you did.
Yeah. Yeah, I did. Okay, so I'll go back up. So that was a thing, is that you always close your resource when you're done with it.
Yeah.
How's that?
Oh, other way around.
Oh, other way.
Multiply.
Okay.
Whether you're setting the time or the time division, so multiply time division by.
And then again.
Good. And show how that changes the display.
Yep.
The date, what did you get on your computer?
But yeah, it'll take a lot less time because we got less data in there. So, because that first one took like 16 seconds the first time, and then that time it took like 8. So
Yeah, that's quite a long time to
yeah, I'm not
pull
sure.
that data.
What
It's
the-
relatively simple.
It
data.
is simple.
Mm.
So that's where I'll kind of. So yeah, there you go. Now it's a little bit
How
smaller.
many data points?
I guess that's where the sample rate comes in, is that
that's
we're
the
looking
sample rate.
at. I'll go ahead and do that.
You have it.
Oh my goodness.
Or you don't detect USB-C.
Yeah, I should just break the rules. Okay. We'll do. So that's that many per second.
Phew, yeah, okay, never mind, that's why.
We're looking at quite a lot of data.
Yeah. Okay, yeah,
Yeah.
that makes sense.
So I think that's going to put the demo on the oscilloscope, right?
Yeah, that's the whole demo on the oscilloscope. I can briefly show you for for the DACs.
Yeah.
You have to use this separate library, which is NI DAC MX. It's managed by National Instruments, so it's their own thing. It worked. You have to have their drivers installed, which is largely what the problem with Mac is that National Instruments has not made a library, or they haven't made one for Mac. Okay, yeah. See, we heard it connect, but
Yeah.
it doesn't connect. So anyway, they don't have it for Mac. They do have it for Linux. So you should be able to do this with a Linux machine. And then you just install the NIDAC-MX library and import it. It mainly works through tasks, which is the same way that LabVIEW working with a if you write LabVIEW like code, I think it's G. If you ever do that instead of the blocky like weird nonsense, then it's the same. They have tasks, I think. And once you open a task, you want to close it. But if you use this kind of format, then it closes it when it gets to the end of the line. There's 4 different types of channels that you can have. So within a task, what you do is you'll have a task that is for analog output or analog input. And when you do that, you can only do output or input on a task. I think you can actually only do analog input or output on a task. And so in which case you just have to make separate tasks. And then the main limitation there is that not a lot of DACs will let you do multiple tasks at the same time. You can have multiple tasks, but they can't be operating sequentially. I haven't tested the full limitations of that. So I would imagine it gets in the way if you want to take in a bunch of analog data and you're also reading like something on digital. And so maybe it's just input output. You can't do it at the same time. I'm not sure. There's something weird that they got mad at me for. I don't, and I'm
Can you, like, for example, let's say you're trying to, like, your computer is managing an oscilloscope and a DAC. Is that too complicated?
Oh, no, yeah, that's totally, yeah, I do that. So
Okay.
in our system, we have an oscilloscope, a digital multimeter, and 2 power supplies, which are all on the Visa.
Okay.
And then we have a DAC, which we're using to run a whole bunch of other stuff. So yeah, you can, as much stuff as you can fit in your computer is what you can plug in.
Okay.
It's quite cool.
Right, yeah.
No, it's good. And actually, if Seth has a few more minutes after this too, you can even show me the shotgun setup and.
Oh yeah,
his thoughts on
I'd love
how
to look at that, yeah.
So happy to do that.
I can go back to and I'll go back through this quick demo with I'll do the truncated version because we've been kind of yapping this whole time. So anyway, this is how you make a channel. So you analog input or an analog output would be AO, and then digital input, digital output. You have to know this is kind of the way that they like to structure their lines. So like for example, this one on the sticker, it'll say P1 and then you have 3 through 0, and those are the lines. And so it's your device, your port, and then the line within the port. And then analog is a lot easier. Usually it's just they'll be labeled AI1, AI2, AI3, and then all the way through, and that makes it a lot easier. The ones you'll want to look out for on analog is your differential versus reference state measurements. So if it allows you to do differential measurements, you have to say, I want to do differential measurements. Otherwise you just plug it in and it references its internal ground. But all of that, they have a Python library documentation, which I think is really detailed. It's almost too detailed. It's hard to know what's going on, so it takes a lot of tinkering. That is something I think I would like to do in our classroom is go over the broad strokes, what's most often used when you're operating a DAC. Because I know what I use and then I don't use anything else. But it's a very extensive documentation. And it's almost too so with NI-DAC-MX. So this is the documentation site, and there's all these things. I use something from Constance and I use task. And then when you go to task, I just go here and oh, I say I want to know something about how a digital input channel, and then it just kind of tells you, and it's not very helpful. So I think it'd be nice if I could put together a better resource that kind of explains it a little bit better, how things work and why they do what they do. I think you can go to the National Instruments website and see what some of their internal stuff is, and they'll explain it a bit better on their site. But this particular documentation is weak, in my opinion. It's very extensive, but it's not a lot of depth. It's a little bit about a lot.
Have you guys tried other DACs?
I haven't
National
tried other
Instruments?
DACs. My imagination is that they would work with the Visa, unless they have their own. What DACs do you usually use?
Oh, I'm completely new to this,
Oh,
so
okay.
I'm like trying to decide.
Actually, Jonathan has one set up in the computer downstairs,
Yeah.
so that might be a good.
Is it National Instruments or?
Yeah,
Okay.
it's an NI.
It's a big one, I can't remember which one.
It's an NI oscilloscope. I think it's the 5516 USB one.
Okay. Yeah, if it's USB, it should work.
USB.
Yeah. Yeah.
Sweet.
So if it's it's weird because National Instruments has their weird stuff. So if it's National Instruments, it might be on their stuff. But this
Okay.
DAC MX, I think it's only for DAC. So they probably use Visa for oscilloscopes. So
Okay.
I don't know. That's kind of the thing that you just gotta play with.
That's enough on Princess oscilloscope.
Yeah.
Question for you, is there any upper limit on sample rate with this?
I think the limit is more on the hardware side. If I
Okay.
your computer. So that's kind of what I was gonna mention is the. Oh, I had a whole bit on. I don't know where it went. Let's see. Oh, this one. The next thing that we use is if you need to run multiple things kind of side by side, you want to talk to multiple devices. You can't with Python natively because the way that it works is it does everything sequentially. You run all of your Python. Only one Python thread can be operating and using the memory at the same time. And to kind of get around that, since input output operations, like you send a query and then you just kind of wait. You don't necessarily, you can, what I do is I set up a bunch of threads using the threading library, which you can make a bunch of smaller Python threads, which all operate on the same memory, and they kind of take turns really fast using my analogy is that it's a bunch of people with a pencil, and they all take turns passing the pencil around really quickly to use the pencil and write. And that works really, really well for input output stuff. So if you have a whole bunch of devices connected, I haven't tested it, but I don't notice a latency in, okay, I'm running all this stuff. I basically need a spontaneous input from all of them at the same time. Obviously that can't happen. I can get one at a time, but it's close enough that I haven't noticed like a deviation to the point where we're like, all right, well, that's clearly weird, right? I haven't noticed that, but there is definitely some amount of loss in that way of running things.
I guess, it's sort of on the acquisition side for us, it's no big deal. For us, it's like, it's all gonna be on the trigger anyway, right? And so
Yeah.
as long as that's simultaneous.
I think
Yeah.
the sample rate is a device thing. So whatever the device limitations are is what you'll be able to output.
Okay. And so as it's recording data, it's likely going to be obviously a very high frequency, but it's going to go, say, one pressure sensor, another pressure sensor to maybe I don't know, whatever
Yeah.
else we have. Currently it's all pressure sensors. But it would just be passing.
And I don't think it has like an order. I
Okay.
think it goes who needs it. So for instance, like pressure sensor is you want to know you query your pressure sensor. When you send the query out, that thread doesn't need to be running anymore. It can kind of idle while it
Right.
waits for a response. So it'll send its query and the next pressure sensor sends a query. And then now
Okay.
that pressure sensor just sent a query, but the other one has information coming back. So then it switches to that one. And it does all
Right.
that pretty well.
Okay.
I think there's probably an upper limit before you start to notice,
Right.
especially if you're doing more complicated. It's just IO, like, okay, I send the
Yeah.
query, receive data. And if you're getting like a big packet of data, it could even like split I'm gonna take a bit, I'm gonna go over here, get a bit.
Yeah.
And I'm not sure how that works internally, to be honest. There could be some limitations on
Yeah.
how much you can do, and then you might start to see time losses. But I mean, we haven't had any issues with it.
But at least with a few sensors, you haven't noticed any like delay.
No, it's definitely, we saw almost an immediate like noticeable improvement over there was a trigger in in LabVIEW, and then you saw depending on when it happened in LabVIEW, because it kind of worked top to bottom, left to right, you could end up with a trigger, and then by the time it gets back up, there was a significant time delay. And you could kind of see it in the code. You could see it executing for too long after a trigger was seen. And then we saw that improved here. But I mean, we're on the order of maybe a second, less than a second. And then since then, I don't know. One of the things I want to do is kind of run some tests. I want to go on LabVIEW, set up a small thing with a trigger and some timing stuff that outputs times, and then do the same thing in Python and see, all right, what are we actually looking at? How much faster is it? And kind of quantify what that delay is. But I don't have that now. But I think it's good. It works for us. I mean, we get I do have in our GUI, I have like a logging thing where it puts out the time that it received information from the sensors, and when I wrote it was sub-milliseconds between them. And but that also includes I received it, now I have to go write this thing to the so I mean there's definitely a lot of complications when you come to timing like that. Threading is probably the most applicable for devices. If you want to do heavy calculations, like when we were managing all that data, right, for the plot, to make that a little bit faster, what you might be able to do is use multiprocessing, which literally creates separate Python instances. Because, all right, we're going to make a Python process that does this, and then one that does this, and then they come together at the end and they share their data. But that's a lot more difficult for kind of this cross communication where I want 6 devices running at once. I get a trigger, they all stop.